Hey, AP Calculus students, Mr. Meunier here again. Hope you're doing well. Today, I want to run through topic 5.2, 5.3, and 5.4. Now, 5.2, I'm not going to really run through. I'm going to hit a couple points about this, just definitions. We're not going to work through these notes, and then use that to help us in 5.3 and 5.4, which are both fairly short and similar topics. We will revisit 5.2 later when we do 5.5. So again, we will revisit this topic at a later date, specifically this extreme value theorem at the front of 5.2. It is important. We're going to hit that though probably later this week. Today though, with this, I really want to talk about this idea of relative extrema and critical numbers. Critical number is something you will be asked to do several times. A critical number occurs when your derivative equals 0 or your derivative is undefined. So again, a critical number means derivative equal to 0 or derivative is undefined. Derivative equal to 0 or derivative undefined is this idea of a critical number. And it's critically important, pun intended, that you understand this and you know this. If you're asked to find a critical number, that means your derivative is 0 or your derivative is undefined. And that's important because derivatives, again, mean slope. And if your derivative is 0, that means there is no slope, which means you're not rising or falling. A positive slope means something is rising, like this section. A negative slope means something is falling, like the second section. And again, a positive slope means a curve is rising. So positive slope means positive derivative. Negative slope means negative derivative. Again, positive slope means positive derivative. But if you're not rising or falling, that means these two values have no slope. 0 slope. 0 slope on each of those. And 0 slope means a 0 derivative, which means a critical number. So these two values, these top and bottoms, are critical numbers. And more than that, we can see this is a maximum. It's a high point. While this is a minimum, a low point. So we have a maximum value and a minimum value, and they occur when we have that no slope, 0 slope, which is a critical number. So finding a critical number is critically important because it leads us to maxes and mins potentially. And finding the max and the min is important across various fields. So that's kind of what today is going to be about, finding critical numbers, finding out when a problem rises, increases with a positive slope, or falls, decreases with a negative slope, and then is it a max and a min? These are called relative maxes and relative minimums, relative max and relative min. Relative because technically this problem moves on forever in each direction. So if this continues to rise forever, our critical number is not, this maximum value is not the max of the entire problem. There's definitely something higher off to the right, but that's definitely a max in its area. And same thing here, this minimum value on the right side of the problem is not the lowest point in the problem. Over on the far left, it gets a lot smaller. It's just as a minimum in its vicinity. So a relative max and a relative mid doesn't necessarily mean it's the highest and lowest point ever. It's just a peak or a valley in the scheme of things. And this little figure here is talking about how, again, critical numbers mean derivative equal to 0, which is the second one. You flatten out, or derivative does not exist. And we talk about derivative not working at sharp turns. Both of those are maximum looking values. So if f has a relative max or a relative min, if you have a max or a min, then you have a critical number. You have a max or a min, then you have a critical number. So that's what I want to talk about with 5.2. We'll come back and revisit some of this at a later day. So 5.3 is really what I want to do most of our work, 5.3. So let's go to 5.3 in the notes. 5.3 talks about increasing and decreasing. So this little figure here, we can see, kind of like what I laid out earlier, if you are decreasing, that means you are falling. That means you have a negative slope. Or for us, that means your derivative is negative. But if you're rising, if you're increasing, that means we have a positive slope. Or for us, that means our derivative is a positive number. If you're not moving up or down at all, this is a segment that's constant. That means you have zero slope, or for us, the derivative equals zero. Most likely, that's going to be a single point, a max or a min point, but it's not unheard of that you have a segment that's constant. So again, negative derivative means decreasing. Positive derivative means increasing. Zero derivative means a constant. We got a problem here to look at. Example 1. The graph shown to the right is of f prime of x, the derivative of f of x. Using the graph, find the critical values of f of x. State the intervals over which f of x is increasing or decreasing. Justify your answer. So big deal here. This is f prime, which is unusual. People have a hard time with that. This is the derivative graph, the derivative graph. Critical numbers, we just defined. That means the derivative equal to zero. So where does the derivative, and this is the derivative, equal zero? Well, at 0, 2, and 4. All of those are critical numbers. So critical numbers at x equals 0, 2, and 4 because f prime of x equal to 0. That's your justification, this because f prime equals 0. You have to say why. So you have to display that you understand the definition of a critical number. Now, critical numbers also happen when derivative is undefined. If you look at this graph, there is no undefined. There is no breaks, there is no asymptotes, there's nothing going on. So we don't have any of those critical numbers. Then it asked us, where are we increasing? And again, increasing means derivative is positive. Derivative is positive. If you're increasing, that means you have a positive slope. That means you're rising. That means the derivative is a positive number. And looking at this, we have a whole lot of positive derivatives in this initial segment and that last segment. Again, this is a derivative graph. So this graph has positive numbers between 0 and 2 and from 4 to infinity. So we will say f of x increases from 0 to 2 and 4 to infinity because, and that's my justify, f prime is greater than 0. Increase between 0 and 2 and 4 to infinity because f prime is greater than 0. And then decreasing, well, that means derivative is a negative number. Well, we have negatives between 2 and 4, and from negative infinity to 0, over here on the left side. All of that's negative, and we're going to assume that goes on forever there. So again, that's a derivative graph, though. That's the graph of the derivative, pulling those off the curve itself. So f of x, the original problem, this is the derivative graph, the original problem decreases from negative infinity to 0 and 2 to 4, and now space, because you're justify f prime is less than 0. So this graph, so the original problem will fall, rise, fall, and then rise again. Now we can do it without a picture too. So this is find the intervals on which f of x equals x cubed minus 3/2 x squared is increasing or decreasing. So again, find increase or decrease. This is f of x, the original problem. So I got to figure out derivatives. So again, f prime positive means increase, f prime negative means decrease. Derivative positive is increase, derivative negative is decrease. But the first thing I have to do is find the derivative. So f prime is x cubed, 3 comes to the front, drop this cube to a squared, 3x squared, minus 3/2 x squared. So 2 comes to the front, 2 times 3/2 is 3, drop it to an x. So there's my derivative. Second step, find the critical numbers. We got to know critical numbers, always. And again, critical number means derivative equal to 0. F prime equal to 0. So 3x squared minus 3x equal to 0. We need to solve this. You probably would not have a calculator for something this small. This is a basic quadratic. It's equal to 0. Try to factor. I'm going to take a 3x out to the front. That leaves x minus 1 behind. So 3x is 0, x minus 1 is 0, x equals 0, x equals 1. So I have critical numbers at 0 and 1. 0 and 1. Again, critical numbers can also occur when your derivative is undefined. This is not going to be undefined. This derivative is not going to have any issues. You typically need to worry about radicals or fractions. Radicals and fractions tend to give you issues. You can't have negative numbers in radicals. You can't have 0 on the bottom of a fraction. So 3, after you find the critical number, set up number line with critical numbers. What I mean by that is, I'll make a number line. 0 and 1 are my critical numbers, so maybe go -2, -1, 0, 1, 2, 3. 0 and 1. Again, those are important. Those are critical numbers. Test values between critical numbers. That's kind of the fourth thing we want to do. Test values in f prime between the critical numbers. So what I mean by that, I have 0 as a critical number. So something before that, any number at all before 0, do not include that though. So maybe f prime of -1. Take -1, plug it into the derivative. I highly recommend if you have a derivative and you factored it, I'm boxing this over here. That's what I would plug it into. I don't care about the number. We care about is it positive or negative number. So if I take -1 and I plug it into 3x, that's a negative. -1 minus 1 is a negative, which means this whole thing is going to be a positive. Again, that tells me that we are positive in this stretch before 0. Pick something between 0 and -1. So maybe 1/2. If I plug 1/2 into 3x, 3 times 1/2 is a positive number. But 1/2 minus 1, again, I'm plugging into this 3x, x minus 1 bit over here, just one piece at a time, because that's easy to find positives and negatives. 1/2 minus 1 is a negative number. A positive times a negative is a negative. So that means between 0 and 1, it's a negative. And then if I plug in something after 1, I'll plug in maybe f prime of 2. Again, do not use 0 or 1. That means the derivative is 0. That's a critical number. Plug in something after it, though, like 2. If I put it in the derivative here, 3 times 2 is a positive number. 2 minus 1 is a positive number. That's a positive. And there's our intervals. So we got to write this out now. The number line's not enough. After that, we got to, write out the solution. So step 5, maybe up here. Write solution. F of x is going to increase when it's a positive derivative. So -infinity to 0 and 1 to infinity. F of x increases from -infinity 0 and 1 to infinity because f prime is greater than 0. And then you would say f of x decreases from 0 to 1, 0 comma 1, because f prime is less than 0. Increase when it's a positive derivative, decrease when it's a negative derivative, critical numbers when the derivative is 0. And then from this, the next thing is just where's maxes and mins going to be, we're going to get to, and we can kind of see that here. If you just think about what's happening here, this problem is going to rise. Positive derivative means it's rising. 0 means you stop, you pause, you flatten out. Negative derivative means you fall. Again, 0 means you pause, and a positive derivative means you're going to rise. So we rise, we fall, we rise. That means that 0 here is a max, and 1 here is a minimum. If you go from a positive to a negative derivative, that's always a maximum. From a negative to a positive, that's going to be a minimum. Rise, fall, positive, fall, negative. Positive to negative makes a max. Negative means you fall. Positive means you rise. That makes a minimum. And that's what 5.4 is. So again, let's skip to 5.4 now. First derivative test. It's what we just discussed. If we go from a negative to a positive derivative, negative to positive derivative, then that's a minimum. If you go from a positive to a negative, then that's a maximum. If you go from a positive to a positive, that's nothing. Negative to a negative, that's nothing. So these are not maxes or mins on the bottom two, but this first one, a negative derivative, again, we're falling. That's a negative derivative. You pause, that's a critical number because there's zero derivative, and then you rise, positive, decrease to increase, minimum, but increase to decrease is a maximum, rise to fall. So let's put it all together. Let's just skip to example C, cut to the chase here. If you want to see the other examples I passed over, you can find the key to the notes in Schoology, obviously. We can talk about that more when we get together. I think one's a little is sufficient here for us, though. So find the relative extrema. This word just means max, min. Extrema means max and min, max and min. So to do that, we got to follow the same steps as before. We got to know the derivative of this thing. So first thing I'm going to do is find the derivative, f prime. Now this is a fraction. So doing the derivative means I have to incorporate the quotient rule. Derivative of the top is 4x cubed times the bottom unchanged is x squared. Subtract in the quotient rule. Derivative of the bottom is 2x times the top unchanged is x to the fourth plus 1 over the bottom part squared. If I clean this up, we're going to get 4x cubed times x squared is 4x to the fifth. Distribute the minus 2x in. So minus 2x to the fifth minus 2x over x squared. Squared is x to the fourth. That's going to give us 2x to the fifth minus 2x over x to the fourth. And finally, I can clean this up. All three of these pieces, 2x to the fifth, 2x, and x to the fourth, have an x in common. So we can, in fact, take an x out. So 2x to the fourth minus 2 over x cubed is our derivative. Then we have to find the critical numbers. Again, that means derivative equal to 0. So 2x to the fourth minus 2 over x cubed equal to 0. Multiply the x cubed over. 0 times anything is 0. So 2x to the fourth minus 2 is 0. From here, I can add the 2. That's 2x to the fourth. Add the 2 and divide by 2. So x to the fourth equals 1. Add 2, divide by 2. Take the fourth root, and x is going to be plus or minus 1. Plus or minus 1. Now, there's another critical number here, though. Remember, critical numbers mean derivatives equal to 0 or f prime is undefined. Well, we're undefined typically when you have fractions, and the bottom of the fraction here can't be 0. So x cubed equal to 0. Bottom of the fraction equal to 0 is going to be a critical number. It's where the derivative is undefined, so x equals 0. So now we have several critical numbers, -1, 0, and +1. We want to put those on a number line like we did before. So again, -2, -1, 0, 1, 2. I have critical numbers, -1, 0, +1. These are all critical. Test values between those critical numbers. Test values between the critical numbers and test them in the derivative. So f prime of -2 maybe. This is a little bit harder. Maybe I'll test f prime of -1/2. F prime of +1/2. and f prime of positive 2. So if you plug -2 in the derivative, if you put a negative to the 4th power, it's going to be a positive. That's going to be a big positive number. A negative to the 3rd power, though, is a negative. It's going to be a positive over a negative, which gives me a negative number. So negatives through there. From negative infinity all the way to -1 is a negative number. If I plug -1/2 in, again, that's going to turn positive, but it's going to get pretty small. It's going to get pretty small when you do that. So again, this -1/2, if I plug it in, that's going to give you a positive, a small positive number, a fractional positive number. Take away 2 is going to make it a negative over, and again, a negative raised to a cubed is a negative. So 2 negatives makes a positive. So we're going to increase between -1 and 0. Positive 1/2, again, if I plug that in, 1/2 to the 4th power is going to be positive. It's going to get really small. If I take the small number and subtract 2, it's going to make a negative. But if I plug a 1/2 into the bottom, 1/2 cubed is going to be a positive. Negative or positive makes a negative number. So negatives. And if I plug 2 in, well, 2 to the 4th is going to get pretty big. It's going to be a positive. 2 cubed is going to be a positive. So a positive over a positive makes a positive. So we're going to decrease, increase, decrease, increase. Okay. So from there, we can say we have a relative max when you change from a positive to a negative. So relative max at x equals 0 I think that's it. Relative max at x equal to 0. Yeah, because f prime changes from positive to negative, and f prime of 0 equals 0. So we have a critical number, f prime of 0 is 0, and f prime changes from positive to negative at x equals 0. Should put that in there. And then we have relative minimums at -1 and +1 because you're changing from a negative to a positive at each of those. X equals -1 and x equals +1 because f prime -1 and f prime +1 equal to 0, and f prime changes from negative to positive at x equals -1 and x equals +1. So relative minimum at x equals -1 and x equals +1 because f prime of -1 and f prime of 1 equals 0. So we establish their critical numbers, and f prime is changing from a negative to a positive at those values of x equals -1 and x equals +1. Again, negative derivative means decrease. It's falling. It pauses at -1. It starts to rise, fall to a rise, again, down. This means we're moving down, then we're moving up, down, up. Minimums at these two, fall to rise, max at the middle one because it goes rise to fall. Don't get lulled into thinking it has to alternate. I want to make that last point. You could go negative to negative or positive to positive in these intervals. You do need to check those. The College Board likes to throw in a tricky one like that to make sure you do check. So always check the values. If you are curious, the graph itself is this 2C. That's what we just did. We can see it falls, bottoms out, it rises. Critical number at -1, critical number at +1. 0 was the undefined critical number. You can see there's an asymptote at 0 occurring. And then again, it falls and it rises. Shoot. My bad. Sorry, guys. Now that I see that again, I realize we did make an error. There is no relative max on this. No relative max because that critical number was undefined. Critical number was undefined. So again, no relative max. That's another little tricky thing. We thought no relative max at x equals 0. So you can't have a max or a min if you're undefined. And that's what's occurring. No relative max at x equals 0. So we have two minimums on this one. Sorry about that. Make that correction. No relative maximum because it's undefined. This problem is undefined. So again, cross out the relative max work. Should have caught that a second ago. My bad. All right, guys, that's it for today. See you back soon. Hope all is well.